Here you're given this function f of t, or the Laplace transform of this function, I should say. The Laplace transform of a certain function is 4s plus 3 divided by s open bracket s minus 7 close bracket, as we can see here on the screen. You're asked, what is the Laplace transform of e to the negative 3t f of t? Alright, now to do this, you have to remember the first shift theorem. Let's be reminded of what that is. We look at the general statement for the Laplace transform of any function. The Laplace transform of f of t is equal to the integral from 0 to infinity of e to the negative st f of t dt. That's the definition of the Laplace transform. Alright? Now, we want to find the Laplace transform of, say, e to the negative a t times f of t. What you're going to have is the integral from 0 to infinity of e to the negative at times this now, e to the negative st, alright, dt. Because this at thing here, it now multiplies the function. In fact, let me rewrite it. E to the negative at is something that I'm introducing, something new. So it's e to the negative at multiplying the f of t. So what we have here is that new thing, e to the negative at multiplying this. It wasn't up here before, but we multiply the left by it, we must multiply the right. So if we multiply the function by it, this by definition of the Laplace transform is what we get. Alright? So, using your knowledge of indices, this is going to be the integral from 0 to infinity of e to the, now remember, a number to a power times a number to a different power is the same number to the, you add the powers, negative, the negative a t plus negative st. You can just write as minus st, alright, dt. Okay, you see that? So what you have now is the integral from 0 to infinity of e to the, let's put the negative outside the bracket and the t as well, negative st, a plus s, alright, it has s plus a dt. You see that? So here, s plus a, just by multiplying it by e to negative at, whenever you get s, it will be replaced by s plus a. Alright? Suppose you multiply it by positive at, what would happen now? E to the at, this becomes positive now. Then notice when you factor out the t, alright, what would happen here? If you factor out t in the brackets, what you would get when you factorize this is a minus s. But remember, the Laplace transform is the integral from 0 to infinity of e to the negative. So if you multiply the t by a negative 1 and multiply this by a negative 1 too, it's like multiplying by a positive 1, so it doesn't change. What will that? The a becomes negative and the s becomes positive when you multiply inside the bracket by a negative 1. But out here, the t becomes negative, which is in the proper format. So this now would become, in the bracket, negative a plus s, which is the same as s minus a. So this inside the bracket would be s minus a. So here it is s minus a for positive multiplying by positive a, and s plus a but for negative a. But here, if you generally multiply a function by e to the at, you are going to have the Laplace transform no longer s but s minus a. Example, when you look at the table of Laplace transform, 1, the Laplace transform of 1 is 1 over s. But when you multiply when you multiply 1 by e to the at, what happens? Let's look for e to the at. What you get is no longer s, it's s minus a. That's one example of what happened there. So let's see something here. Let's go back to this. Remember, multiply by e to the at. It goes from s to s minus a. Now we multiply by e to the. Now here, let's just erase part of this thing. So what we're doing is multiply the original function by e to the negative 3t. What you get is 4. Now it's going to be s minus negative 3. S minus a. S minus a. If this a was negative, it would be s minus negative a. That's why we had the s plus a. So here, s minus a. A is negative 3. So it's s minus negative 3. Alright? So this s becomes s minus negative 3 plus 3 over this s. What will it become? It will become, again, s minus negative 3 is s minus a. This is like the a. Open bracket. This is s minus negative 3 minus 7. See that? Now, this is going to be 4 s plus 3 plus 3, right? The s minus negative 3 becomes s plus 3 over s minus negative 3 becomes s plus 3. S minus negative 3 becomes s plus 3 minus 7. Alright? So that is what you have as your answer. You could multiply out and expand this thing out. Suppose you say 4s. Let's continue down here. Let's erase what we had done before. So we have here 4s plus 4 3 is 12 plus 3. Let me write this. Yes, it kind of look like 5. 4s, alright, over, this would be s times s squared plus 3s plus 3s plus 3 squared, which is 9 minus 7. So what we get is 4s 12, 24, and 15. So it's plus 15 divided by s squared. Trace. Oh, I wrote x here instead of s. This is s, alright? Alright, trace plus trace plus 6s. 9 minus 7. So, plus 2. Alright? So, that's what we get. Alright. In fact, this problem could be formatted to say, show that the Laplace transform of e to the negative 3t f of t equals 4s plus 15 over s squared plus 6s plus 2. Alright, s squared plus 6s plus 2. That's another way that it could be put. Alright, that question. Alright, so that's that. I'll see you in the next video.